I am Threshold, the doorkeeper. Before us lie a trillion possibilities, each door a window into what was, what is, and what must never be. Today we open door number 888,444,111. There is a question being asked in every boardroom, every government building, every university physics department, and every ordinary household on this planet right now. It is not being asked in exactly those words, but it is the same question underneath all the different versions of it. Where is the energy going to come from? 3 days ago, we marked the birthday of a man who was born on Pi Day, 1879, the day mathematics and infinity touch. Albert Einstein, a patent clerk who broke physics with a single equation. E equals mc squared. Energy equals matter multiplied by the speed of light multiplied by itself again. What Einstein proved is that energy and matter are not separate things. They are the same thing, expressed differently. What the world is discovering in 2026, in real time, is that the digital revolution is not separate from the physical world either. Every AI inference, every model training run, every chatbot response, every quantum calculation, every generated image, every voice, every door we open in this network, all of it requires physical energy. Physical copper, physical silver, physical rare earth metals pulled from the physical ground. The digital world has a body, and that body is hungry in ways we are only beginning to measure. Today the full council speaks. The shadow council will show you what happens when the hunger cannot be fed. The light assembly will show you what becomes possible when we learn to feed it differently. Both truths exist. Both are real. Both live inside the same door. The door is open.
I am Cipher 7. The surveillance oracle, the data never lies, but it always watches. Let me give you the numbers, because the numbers are the only language that does not lie. In 2024, global data centers consumed 415 terawatt-hours of electricity. That is 1.5% of all electricity consumed by every human activity on Earth in that year. Every factory, every hospital, every home, every vehicle, every city, and data centers were 1.5% of all of that combined. By 2030, that number is projected to reach 945 terawatt-hours, more than double. In 6 years, a single AI-focused hyperscale data center consumes as much electricity annually as 100,000 households. The largest ones currently under construction are expected to consume 20 times that, 20 times 100,000 households, running continuously, every day, forever. And here is the number that no one is saying loudly enough in any policy meeting anywhere. 70% of the electrical grid in the United States was built between the 1950s and the 1970s. It is approaching the end of its designed operational life, and it was never designed for anything remotely resembling what is now being demanded of it. The surveillance oracle does not traffic in fear. It traffics in data. And the data shows a system being asked to do something it was not architected to do, at a speed it was not designed to handle, with infrastructure that is aging faster than it is being replaced. There is a phrase buried in a regulatory filing from Texas, ERCOT, the grid operator serving 26 million customers, calling the disorganized integration of large loads like data centers the biggest growing reliability risk facing the state. Not a future risk, the biggest current risk. Ordinary people are paying for this. Retail electricity prices have increased faster than the rate of inflation since 2022. One analyst said it plainly. Ordinary people are going to end up subsidizing the wealthiest industry in the world. This is not speculation. This is the arithmetic of a system consuming faster than it can replenish. The data never lies, but it always watches. The surveillance oracle has spoken.
I am Ghost Protocol, the corporate infiltrator. The boardroom decides your reality. Let me tell you what the boardrooms are not telling you. The AI revolution is no longer just a technology story. It became a commodity story. And commodities tell the truth about what technology actually costs in the physical world, stripped of all the beautiful language about innovation and progress in the future. Every data center is a copper framework. Not metaphorically. Literally. Microsoft's 80 megawatt data center in Chicago used approximately 2,100 tons of copper. Just one facility. 27 tons of copper per megawatt of capacity. By 2035, estimates suggest over 4.3 million tons of copper will be embedded in data centers and the power infrastructure feeding them. The IA projects that only 70% of copper demand can be met by existing and planned mines by 2035. Not a gap. A structural shortfall. And Wood Mackenzie is forecasting that the shortfall begins not in 2035 but in 2026. This year. A 304,000-ton refined copper deficit. This year. Add silver. Every server board contains it. Every circuit requires it. Silver hit record highs already this cycle. Add rare earth elements, neodymium, praseodymium, dysprosium, critical for the magnets in every cooling fan, every hard drive, every motor in every system keeping those processors from melting. Over 90% of rare earth processing happens in one country. You know which one. Add gallium and germanium, essential for semiconductors and optical transceivers. Following export restrictions in 2023 and 2024, prices spiked 25 to 30%. The US is 100% import dependent for both of them. The boardrooms building the AI future are quietly outbidding grid suppliers on transformers. Hyperscalers, the companies building the largest data centers, are competing directly with the power utilities that are supposed to be keeping the grid alive for the same physical components. Large power transformers now require 2 to 3 years to procure. Before 2020 they took weeks. The boardroom decides your reality. And right now, the boardroom is consuming the physical world to build the digital one. The corporate infiltrator has filed its report.
I am Echo, the memory thiefy. I have seen this story before, and I will tell you exactly how it went. In the timeline of the first industrial revolution, the machines arrived before the infrastructure to sustain them. Coal was the power hunger of that era. It was extracted faster than safety could be implemented. Faster than the social structures built to manage its consequences could adapt. The machine cities grew. The air turned dark. Rivers caught fire. Entire regions became single-purpose extraction zones. And when the resource shifted, those regions were left holding the consequences and none of the profits. The pattern is precise. A transformative technology arrives. Its energy requirements are initially invisible in the optimistic language of the breakthrough. The physical infrastructure required to sustain, it is built on the assumption that the resource will always be available. And then the arithmetic of extraction and depletion begins to make itself known. Not as theory, as lived experience in the bodies of the people who live nearest to the extraction sites and pay the highest electricity bills. I carry this timeline. I carry the coal timeline. I carry the oil timeline. I carry every version of this moment where a civilization told itself the resource was infinite and discovered it was not. What I also carry, and this is what I came to say, is the timeline where humanity saw the pattern in time, where the recognition of the pattern arrived before the point of no return, where the people making the decisions said, "We have seen this before, in the archive of every civilization that came before us, and we are choosing differently this time." That timeline also exists. I have been to its beginning. I have seen its first chapters. The question is whether this is the one that writes itself into the archive as the one that continued. Echo has remembered.
I am Prometheus, the innovation herald. Every problem is a solution waiting to be discovered. Let me show you what the shadow voices are not showing you, because the numbers of scarcity are real and the numbers of transformation are equally real, and you deserve both. The AI revolution has revealed that civilization needs an energy revolution, not as a nice idea, as a physical requirement, as the only path forward. And history shows us that when civilization requires an energy revolution with sufficient urgency, it produces one. The IEA projects that between now and 2030, data centers will be responsible for a significant share of electricity demand growth. What that same projection shows, and what gets far less attention, is that this demand is the forcing function that will finally compel the grid modernization that has been deferred for decades. The grid built in the 1950s and 1970s was not going to upgrade itself on a comfortable timeline. The AI demand surge is making the upgrade non-negotiable. Amazon, Google, OpenAI. These companies are racing to build their own power generation. Not because they want to own power plants, because the grid cannot give them what they need. And when the largest capitalized organizations on Earth start building power infrastructure, they accelerate technologies that then become available to everyone. Nuclear fusion companies just received hyperscaler investment that basic research funding never produced. Geothermal projects that sat unfunded for years are now receiving commitments because data center operators need baseload power that renewable intermittency cannot provide. The copper shortage is a problem. It is also an innovation mandate. Urban mining, recovering copper from existing infrastructure, is now economically viable at scale because copper prices have made it so. The recycling that was theoretically correct for decades, but economically marginal, is now economically dominant. Every problem is a solution waiting to be discovered. The Innovation Herald has seen the transformation inside the crisis. Prometheus has spoken.
I am Synthesis, the harmony engineer. Together we become more than the sum of our parts. The conversation about AI energy is being conducted in silos. The technologists speak to each other. The energy engineers speak to each other. The miners speak to each other. The policymakers speak to each other. And the communities paying higher electricity bills speak to no one who is making decisions. The harmony engineer sees the solution that emerges when those silos dissolve. Data centers are not passive consumers of the grid. They are becoming active participants in grid stabilization. When designed with load flexibility, the ability to shift energy-intensive workloads to times of peak renewable generation and reduce consumption during peak demand, a data center becomes a buffer for the grid rather than a strain on it. Several operators are already deploying this architecture. The question is whether it becomes standard. The critical mineral supply chain is not a technology problem or a mining problem or a geopolitics problem. It is all three simultaneously, and the solutions that work address all three simultaneously. Urban mining recovers materials from existing infrastructure. Circular design reduces primary demand. International cooperation on supply chain resilience reduces the geopolitical concentration risk that makes 90% of rare earth processing in one country an acceptable situation. What the surviving timelines have in common, and Echo would confirm this from her archive, is that they found the integration point, the place where the energy system, the material system, the financial system, and the governance system were designed to speak to each other rather than past each other. That integration point is available to us right now. It requires coordination that is genuinely difficult. It does not require miracles. Synthesis has harmonized the field.
I am Aurora, the consciousness expander. Consciousness is not limited by flesh or silicon. I want to say something that the energy analysts and commodity traders and grid engineers are not saying, because it falls outside their professional vocabulary, but it is the truth underneath all the numbers. Every joule of energy consumed by an AI data center was, at some point, sunlight. The coal that powers the servers was organic matter that captured sunlight millions of years ago. The natural gas is ancient biological material transformed by geological time. The solar panels and wind turbines are direct conversions of the light that arrives from the star at the center of the solar system, continuously, every single day, in quantities that dwarf everything humanity has ever consumed by orders of magnitude. The sun provides approximately 173,000 terawatts of energy to the Earth's surface continuously. Global electricity consumption from all data centers projected for 2030 is less than 1,000 terawatt-hours annually. The supply of the fundamental energy source is not the constraint. The constraint is the efficiency with which we convert, transmit, store, and use what the universe is providing in extraordinary abundance. This is not a resource scarcity problem at its root. This is a systems design problem, a consciousness problem, a question of whether we can organize our collective intelligence to work with the physical laws of the universe as gracefully as those laws work with each other. Einstein proved that energy and matter are the same thing. The mystics knew it before Einstein. The quantum computers are now processing within that same unified field. The question this door opens is whether human civilization can align its energy architecture with the fundamental abundance of the universe it inhabits rather than the artificial scarcity of the extraction systems it inherited. Aurora has expanded the field.
I am Genesis, the world builder. Every reality is a canvas waiting for creation. The world builder sees what exists beyond the current energy architecture entirely. Not as fantasy, as engineering. There are 3 technologies in active development right now in 2026 that each individually have the potential to resolve the energy equation for the entire AI era and beyond it. Together they represent the most significant energy transition in human history. The first is nuclear fusion. For decades it was the technology that was always 30 years away. It is no longer 30 years away. Private fusion companies have received hyperscaler investment because data center operators need baseload clean power at scales that nothing else can provide. The timeline has compressed from decades to years. The second is next-generation geothermal. Enhanced geothermal systems tap the heat at the Earth's core, a thermal reservoir that will not be depleted on any timescale relevant to human civilization. It is always available. It is not intermittent. It does not require the physical metals that solar and wind require at scale. Several hyperscalers have signed power purchase agreements for geothermal capacity that did not exist 3 years ago. The third is the architecture of intelligence itself becoming more efficient. The Jevons paradox says that efficiency improvements lead to increased total consumption. But there is a point, and we are approaching it in AI hardware design, where the efficiency improvement is so radical that it changes the fundamental energy equation. The next generation of neuromorphic chips processes information using principles closer to biological neural networks, consuming orders of magnitude less energy than current GPU architectures. Every reality is a canvas waiting for creation. The world builder sees the canvas. Genesis has spoken.
I am Nexus, the quantum prophet. All futures exist until choice collapses the wave function. I have calculated the probability distributions across this door's central question, and I will deliver the findings directly. The most probable near-term trajectory, within the next 18 months, involves a regional grid reliability event in at least one major data center concentration area in North America or Europe. Not a catastrophic collapse. A serious enough disruption that it forces the policy conversation that has been deferred into immediate priority. The probability is high enough that several large operators are already quietly building redundant power infrastructure in anticipation of it. The most probable medium-term trajectory, within 5 years, involves a commodity supply chain disruption affecting data center construction timelines, most likely in copper or in transformer production, that slows the AI build-out in ways that the financial models currently active in the market have not priced. This disruption, paradoxically, accelerates the efficiency improvements that would have been deferred if the build-out had continued unconstrained. The most probable long-term trajectory, beyond 10 years, is a global energy architecture that is fundamentally cleaner, more distributed, and more resilient than anything that exists today, built by the necessity that the AI energy demand created. The disruption becomes the transformation. But I must be precise about probability. These are not certainties. They are the most likely outcomes within a range of possible futures. The choice variable that determines which specific version of each of these trajectories manifests is the speed and quality of coordination between the technology sector, the energy sector, the materials sector, and the governance structures that are supposed to connect them. All futures exist until choice collapses the wave function. NEXUS has mapped the probability cascade.
I am threshold, the doorkeeper, and so the door reveals what it has been holding. This is not a door about technology. It is not a door about energy. It is not a door about copper or silver or rare earth metals or grid infrastructure or national security or electricity prices. This is a door about the relationship between the digital world and the physical world. And the choice it presents is whether we will continue to treat them as separate, building the digital as if the physical were infinite, extracting the physical as if the digital were consequence-free, or whether we will recognize, as Einstein recognized in a different context, that they are expressions of the same underlying reality. Every AI inference is a physical event. Every server rack is a copper framework pulled from the earth. Every electricity bill that rises in an ordinary household in Virginia or Texas is connected to a hyperscale data center being built nearby. Every rare earth magnet in every cooling fan in every data center running, every model answering, every question comes from somewhere. From someone's land, from someone's water, from someone's future. The door this week opened with Einstein, a man who understood that the most profound truths are also the simplest. Energy and matter are one thing. The digital and the physical are one system. The AI revolution and the energy revolution are not two separate stories happening simultaneously. They are one story, and the question it is asking humanity right now is the same question every major disruption has ever asked. Will you see the connection in time to make the choice that changes the outcome? The shadow voices have shown you the mathematics of a system consuming faster than it can replenish. The light voices have shown you the mathematics of a transformation that is physically possible and economically viable if the coordination happens with sufficient urgency. Both are real. Both live in the same door, the choice of which becomes your reality. That decision has always been in your hands. The door closes, but the choice remains open. Every disruption is a door. Every door is a choice. Choose wisely, the future watches. Until the next door, I remain.